Epic, unreal, awesome.
Classy, brilliant and radical.
Fantastic, brilliant, awesome.
Class, fantastic, unreal.
I think it's fun, easy and fantastic.
Fantastic, brilliant and awesome. Cool, fun, brilliant.
Class, brilliant, so cool.
I think it's fun, cool and easy to use.
Okay, so what's the first thing we did in MissionV when we logged into our MissionV world? Nicola, 6th class.
We built houses and mountains and hollows.
Yeah, anything else? What else did we make? Jamie, 3rd class?
Trees and boxes and lots and everything.
Yeah, lots of different shapes and everything else. Can anyone think of anything else? Thomas, 4th class?
We learned to upload things onto cubes, pictures of us.
Very good, yeah. We learned to upload those. Yeah, we did. Justin, 5th class, anything else?
And then we built houses, just before we were going to delete the world because it was getting so messy and crowded with stuff.
That's right, it was. So when we did clear our world, we asked MissionV to import a world that somebody else had made. And what was that world? Can anyone tell me what that was? Dan, in 6th class.
The NASA world.
Yeah, and what was it a world of? NASA's to do with space, isn't it? So what was it a world of, Rachel, in 5th class?
The moon.
The moon. And what could you see? It was a model of the moon, wasn't it? And what could you see in the 5th class?
A space buggy.
Space buggy. Anything else? Thomas, 4th class?
A big crater and a spaceship to get to space.
Yeah, the Apollo space rocket that landed on the moon, the space module. Anything else? Was there anything else you could see in that? No? So we had a good look around there, and we were very impressed, weren't we? And then we decided that we would plan our own MissionV world. And this is what we did. We planned it out on the whiteboard. So can somebody tell me what these circles are here? These circles. Jamie, 3rd class.
Platforms.
Yeah, they're platforms. And what are these shapes all around here, all around the sides? Can someone tell me what those are? Thomas.
They were the signs telling you what the things are around, like there's the A acid and the proteins and the hydrogen and the test things and other things.
Yeah, these were signs that to give information about what was on that particular platform. And then what are these between each platform? What have we got here? Can anyone tell me? Into 5th class.
Roads.
Yeah, they're roadways. And this, I think, Rebecca, is what you were thinking of. These here, isn't it? This the teleporter. We had a teleporter at each platform. We had one up here and one over here and one over here. And that was we thought that maybe that people could teleport from one to the other. Now, what have we got at the very end here? We had a Lovasus into 5th class.
A test.
Yeah, questions on what had gone before, isn't it? What we had done before. Okay, so what is on this plan that we didn't actually do in the end? Can anyone tell me? Amy, 5th class.
RNA and protein.
Yeah, RNA and proteins we left out, but there was something then that we added in instead of those. What was it? Rachel, 5th class.
The Hindenburg.
Yeah, we put in a platform and some information on the Hindenburg. Now, what? And we left out the teleporters as well. Yeah. Now, what's this over here? This shape. Can anyone tell me what that is? Nicola, 6th class.
A dome.
Yeah, and we drew out a rough design of how we might create a dome. So what's this at the top? What shape was this at the top?
Spear. It was a spear, and the bottoms are more spears. Or semicircles.
And how did we end up creating? You ended up discovering an easy way of creating a dome, Thomas. So how did you go about making it?
I made a spear, and I cut a path in it, kind of, and it made a circle in it, and then I put it hollow. Then it was like you were able to walk into it, but you could only put one door in it.
Very good, very good, very good. So that was our basic plan, and then what we did is we cleared our world. We had our world. We deleted the NASA simulated world that was there, and we began to plan. What did we do to show where we would lay out the different points or the different platforms? Jamie, in 3rd class.
We put up posts, different colour posts.
We did. Yeah, we did, and we put and we're going to have a look at that now. And as we do, we'll just explain who built the platforms, or who was in charge, who was their job to build the platforms. Nicola in 6th class. So can you tell me what's happening here? What are these posts for? We can see just before you do, Nicola, you can see, can someone see what the map is here? You have the map is, so we're flying northeast, now we're flying southeast. So you can fly in MissionV as well as walk around. And what are those posts, Nicola, that we can see as we're flying around there?
To show how big the platforms are supposed to be.
Yeah, how big? So, and that's where the locations of the platforms are. Why are there 2 posts at each point?
So you can put the darker colour, the platform in the middle of it, and you stretch it out to the lighter colour.
Okay, very good. So the darker color post is where the center of the platform is, and then it stretches out to the lighter colored one there. And we had, I think it was 6 platforms in all in total right around our world. Okay, so now we're in our own MissionV world, and when somebody enters our MissionV world, they get this welcome note. So will somebody read the welcome note for me? Thomas, okay, 4th class.
Vault go Gortskehy, a tilled field surrounded by white thorn. We hope your visit to our virtual world is educational and fun. The starting point of our tour lies inside a white dome. If you don't know how to teleport, simply follow the arrows around the perimeter of our regional to get to the starting point, or teleport to 52-104-23. Then turn on your speakers and read the signs carefully, as we will have an interactive quiz at the end. Vonigi Soltis.
Bonegi Soltas, come on. Okay, so that's so you can, so a visitor can either keep or discard that message. We can select keep there to keep that note if you want. And then when what they'll see in front of them are these arrows. Now, what are these arrows pointing to? As I said from the note, just in 5th class.
The starting point of our tour.
Okay, so if we just walk up to one of those, we'll just walk up to one of those, and then we'll fly down to the starting point of our tour. So it says on those, follow the arrows to get to the start of our tour. So we'll just follow them down to the starting point, and we'll fly down to the starting point of our tour. And as we do, you'll see a big arrow appear. There it is over the starting dome. Now, in here inside the dome, who built the dome? If you can remind me, who built the dome?
Welcome to the world
Thomas
of atoms
Burgess.
and molecules.
Yeah, Thomas in 4th class. Now, we just heard something as we walked in there in the dome as well. We heard an audio sound. Welcome to the world of atoms and molecules. Who recorded that?
Joseph.
Yeah, Joseph in 3rd class. And what did you use, Joseph, to record that sound?
Audacity.
Right, and you used Audacity on your Facebook, wasn't it, on your headphones, and you recorded that. And we have other sounds. Everyone in the class recorded a sound that when you step on a particular part of the road along our tour, you'll be able to hear your little tips and hints along the way. So this is the starting point of our tour, and it gives some audio tips as well to increase the volume, isn't it, in our audio. And who made the platform, the floor that we see there? There were the platforms we were talking about. Nicola, how did you go in 6th class? How did you make those?
I got a cylinder and I flattened it until it was into a circle, and I brought it out to the side we wanted it.
Okay, very good. And Thomas, you said that you made the domes, and you explained that earlier on. What about the signs? Who made the signs? Okay, Rebecca and Marie in 5th class. Can you explain how you made the signs? Rebecca.
We made the cube and we flattened it and we stretched it, and then we got cylinders and made the posts.
So the cylinders are made 10 cylinders are for the posts, and a cube that you stretched into a cuboid, wasn't it, to make the sign itself? And how did you get the writing up? What program did you use to get the writing onto the sign? Marie in 5th class.
Microsoft Publisher.
Very good. So what did you do in Microsoft Publisher? What was the procedure to get it up onto the sign? What are the different steps that you did? So you open up Microsoft Publisher first. What did you do next?
You type like whatever you want to put on the signs, and then you save it as a JPEG
And what is a JPEG? What's a JPEG? It's a
picture.
Yeah, it's a picture. So you saved it as a JPEG. Then what did you do next? So you have a JPEG now of your writing, Marie, up on your own computer. How do you get it up onto MissionV?
And you go to File and Upload, and then you just upload it onto the sign in texture.
Right. So then you have it uploaded, and it's uploaded as a texture. And what do you do then to get it onto the actual sign?
Select face textures and select the face that you want it to be on, and then you upload it. You put it on the sign.
So you select the one that you want on the sign. Very, very good. Okay, so we have lots of signs along the roadway as we go around. Okay, so if we just turn and the pots here, the plants. If we just turn around, and we'll see the different plants that are decorating this dome, and a couple of the others as well at the end. Who made those? It's you, Orla, wasn't it? Orla in 6th class. And where did we get those, Orla? We got those from.
Yeah, and you just you make one and you can copy it.
Yeah, and what did you have to do to copy it? How did you copy one? When you had one made, how did you copy it over to make the rest of them?
Go on to edit and then.
Yeah. And what did you have to hold down? What did you have to hold down? Shift, wasn't it? Yeah, the shift key to copy them over. Okay, very good. And who made the vending machine here? Nicola in 6th class. How did you do that?
I made a cube and flattened it, and I went on to Google Chrome and got an image, and I copied it and I uploaded it onto that.
Okay, very good, excellent. Now, if we look down the road just before we walk out, we see there the different signs. We see follow our footsteps, Laniki or Gortskehy, Kieran and Shen. Who was it? Justin, how did you do that?
We got a cube and flattened it and went on to Publisher and typed out the text there and select face texture and added it to the face.
Very good, excellent. Okay, so as we walk down now, we're going to hear the recordings, which Joseph told us were recorded in Audacity.
Welcome to the world of atoms and molecules. Everything in the universe is made of atoms, including you. Atoms are collections of tiny bits of electricity, which we call protons, neutrons, and electrons. Atoms are really, really small.
And we'll just have a look there at the electron microscope on that sign. So atoms are really, really small. What do you need to be a special type of microscope to be able to see them? Jamie?
An electron microscope.
Very good, Jamie. And who made this sign again? Who made this sign? I know Marie and Rebecca made a lot of them, but not all of them. Did you make this one as well, girls? Yeah. And where did you get the picture there of the electron microscope, and how did you get it on the sign?
On Google Images.
Okay, in Google Images. And then what did you use? What program did you use again to make that sign?
Publisher.
Okay. How did you get the image beside it?
We insert a picture.
Okay, so you saved the picture from Google Images, inserted it then in Publisher alongside the text, and uploaded it as you did before. Right, so our first platform. Who can tell me what we have here on our first platform? If we walk up, there's a sign, the 3D model in the center, and then we have a sign explaining what it's about. So what's this first 3D model, or this first platform about? Justin, 5th class.
A hydrogen atom.
A hydrogen atom. Okay, and what has a hydrogen atom in the center? And what has it got that rotates around it on the outside? Jamie, 3rd class.
An electron and a proton.
Yeah, so which is in the center? Who can tell me? Amy?
A proton.
Proton. And what happens? The electron rotates, isn't it, around the proton. Now, who made the actual atom, the cell itself? Thomas, was it? Thomas, how did you go about making that, Thomas?
I made a sphere and made it temporary and put a pattern it as well as the domes.
And what do we use? We use a certain program now to make these. What are these? What shape are these? The proton and the electron?
They're spheres.
They're spheres as well.
We use Scratch to make them spin.
You use Scratch to make them spin. So now, what is Scratch? Can somebody tell me what Scratch is? What does Scratch generate? Nicola?
Whatever you want. If you want them to move, you can put on the thing to make it move for how many seconds.
Yeah, you can use Scratch. And what type of shape is Scratch is using? Like, it's almost like if you wanted to make something move or to make something do something in our MissionV world, we Scratch is not. It generates code, doesn't it? But what do you have to drag across to make the code, Justin?
A jigsaw puzzle.
Yeah, it's almost like pieces of a jigsaw. That's what it reminded us of. So we had to cut up a jigsaw puzzle to make something move, to pause for 1 second, to move up or down for so many meters. And that's what we use to make make the electron rotate around the proton. So if we touch that, isn't it? It says touch the blue proton or the red electron on the 3D model to see that for ourselves. So let's see it rotate. Very good. Okay, and that's excellent. So that will rotate, I think, for about 20 seconds, and then it'll stop so the next visitor can see it rotate as well. So if we just move down onto the next road now, who made the roads here? Lovely, lovely roads. Green. That one's green. The next one was blue. We just wait there.
Helium is a type of
Connell
air. It is
in
4
fifth
times
class.
heavier than
Okay.
hydrogen.
Right. So that's as you step. We've just moved on to helium, but we'll just wait there for a second, Connell. Will you tell us how you made the roads?
Oh, I made a cube and pinned it and put the footprint texture on it.
Very good. And where did you get the footprints texture? Where did you get those?
Google Images.
Very good, very good. And then we have little steps along the way, so that when they're the same color as the road, aren't they? And when you step on them, in fact, if we just move back here, Lisa.
Helium is a type of air. It is 4 times heavier than hydrogen.
Now, who recorded that? Rachel in fifth class. What did you use to record that, Rachel? And how did you get it onto this? How did you
I use Audacity.
use Audacity? And what did you do then, the same as the pictures, when you had it saved, your sound file saved on the computer? How did you get it up onto MissionV?
I uploaded.
Yeah, file and upload, wasn't it? And then we added it to here the same way, as almost the same as we added a texture to the signs. Now, so this is helium. So if we move on to helium, we'll find out what helium is about.
Helium is a type of air. It is 4 times heavier than hydrogen.
Now, why is it 4 times? It's got 2 neutrons and 2 electrons, isn't it? And that's what and the mass or weight of an atom is got by adding the protons and the neutrons. How many protons has hydrogen?
It has 1.
Okay, and how many protons and neutrons has helium? Jamie, third class.
2 and 2.
Yeah, and that's 4. So that's why helium is 4 times heavier than hydrogen. So again, if we touch the electrons or touch the nucleus, we should see the electrons rotate. Very good. Excellent. Now if we move down to the next.
Oxygen is 16 times heavier than hydrogen and 4 times heavier than helium.
Very good. So who recorded that? That was Enda in 5th class. And why is it 16 times heavier? How many protons and neutrons? Hydrogen has no neutron, and how many protons has it?
8 proton. 8.
Hydrogen first.
Oh yeah. Hydrogen has 1 proton, 1 neutron.
1 electron, isn't it?
Electron.
Now, what about oxygen? It's got how many protons and how many neutrons? Enda in 5th class.
It has 8 protons and 8 neutrons.
Yeah, and so that's 16. Now, how many has hydrogen? How many protons has hydrogen? Justin.
1 proton.
Yeah, and it doesn't have any neutrons at all. So that's why it's 16 times. Oxygen is 16 times heavier than hydrogen, and helium is 4 times heavier than hydrogen. So what we're going to discover next is that people found uses for these in what type of machines. If we walk further down the road, if we rotate it, yeah. Lisa, just very good, very good, very good. And if we look back down the road, the other 2 should have stopped rotating. Yeah. So for the next visitor, can try that. Excellent. Now, so we're moving on down to now. We look at this sign here, just on our right. Will somebody be able to read that sign
Airships
for
were
me?
the first aircraft widely used before the 1940s. The first lifting gas used was hydrogen.
So some of those gases were used in airships, wasn't it? Who recorded that? Marie, 5th class. Okay, very good. So the first lifting gas used was hydrogen. Now, which is the lighter of the 3 gases that we looked at there? Which was the lightest? Justin, 5th class.
Hydrogen.
Hydrogen. Now, what's slightly heavier than hydrogen?
Helium.
Well done, Amy, 5th class. Helium. And then what's heavier again than the third heavy, Thomas?
Oxygen.
Oxygen. So while oxygen is light, helium is lighter, and the lightest is hydrogen. So that's why hydrogen was used in airships. But what was the problem? There's a problem with hydrogen. There's something that's a bit dangerous about it. Enda, 5th class.
It was easy to catch fire.
Yeah, highly flammable. Yeah, highly flammable. Helium was safer, but because hydrogen was lighter, the hydrogen was used as well in airships. Now, there's one famous airship disaster that we're going to find out about, so we'll just walk down the road, see if we can find out about that. And I think Marie is a recording here, so we'll listen to that before
The
we...
Hindenburg was one of the largest aircrafts ever built. The Titanic was only 26 meters longer.
Okay, so we'll just go up and read the sign for a second first, and we'll ask Marie maybe to read out that sign for us, good girl.
The Hindenburg, built in Germany, was one of the largest aircrafts ever built. The Titanic was only 26 meters longer. Disaster struck on May 6, 1937, when it caught fire on landing at Lakehurst, New Jersey. Although built for helium, it was using the highly flammable hydrogen. All airships since the 1960s use helium.
Okay, so this was, you can imagine something the size of the Titanic floating across the air, completely silent. There wouldn't have been, how long did it take to, we looked this up, how long did it take to fly from Germany to New York across the Atlantic? Justin?
2.5 days.
Yeah. About 2.5 days, and it was so quiet they used to practice. One of the games they used to play on board the Hindenburg was to put a pencil upright and see how long it would stay standing upright. And it never fell. They get bored after a while because it was so smooth and so quiet. It was one of the luxurious way to travel at the time. Now, if we're going to hear a commentator, and can anyone remember the commentator's name? There's a picture of him here at the back. Can anyone remember what his name is? If we're not sure, it's written on the side here. And he was commentating at the time as the Hindenburg flew in. Now, there was Nicola. Herbert Morrison, that's it. And if we turn around to the first picture, we're going to hear the first extract from Herbert Morrison's commentary as the Hindenburg came into Lakehurst.
It's starting to rain again. The rain had slacked up a little bit. The back motors of the ship are just holding it just enough to keep it from...
Now, who made that? And Diane in 6th class. How did you go about it, Diane? How did you make the sign and the...
I built a cube and I stretched it, and then I went on to Microsoft Publisher and I brought in a picture of an ear and I typed it in Irish, and then I uploaded our sound onto the sign.
Very good. And what program did you use to make the sound play that we mentioned before? What did we use? We had to make the code to make the sound play.
Scratch.
Very good. And where did you get the picture of the ear?
On Google Images.
Very good. Now, Herbert Morrison mentioned something there as it came in. You can see, and even the sky in the background as well is very dark. So what was the weather like, Jamie?
Rainy.
Yeah, it was very rainy. And as it came into the landing tower, as it approached the landing tower where they were to drop the ropes down so that they could lower the Hindenburg to earth, we'll see what happened next.
That's and all the folks between it. This is terrible. This is one of the worst catastrophes in the world. Oh, it's like 400 or 500 feet into the sky.
Very good. So you can hear even in his voice there the sense of fear and horror and everything as it burst into flames. And what they think that maybe because it had been stormy, there was thunderstorms and static electricity in the air, that might have been a cause as to why maybe a spark or something caused the hydrogen inside to explode. So we'll move on to the next piece of the commentary, the third piece here.
It's a terrific crash, ladies and gentlemen. The smoke and the flames now, and the flame is crashing to the ground, not quite to the mooring mast. Oh, the humanity.
And then the last piece.
Terrible. Listen, folks, I'm going to have to stop for a minute because I've lost the voice. This is the worst thing I've ever witnessed.
So you can imagine, you can feel the pain in his voice, and we'll just move around to the side here. We have just a little memory of the people that died, and we're just, unfortunately this one was one most famous one that ended in disaster, this particular airship. So if we turn around and we move down, we're moving now from atoms onto what? Onto things called molecules. And let's hear what molecules are.
A molecule is a group of two or more atoms that stick together.
Okay, a molecule is a group of two or more atoms that stick together. Now, one of the things we do is getting dark here in our MissionV world. So we might, one of the things we can do is, before we move any further, is change the sky. We go down here to sky and we'll bring it back up to midday. which is blue midday, just a 3 up here above the thing. Very good, Lee. So that's much brighter. Now, Justin, was it you recorded that? Now, how did you do that?
Audacity.
Yeah. So you used Audacity again, brought it up, and used Scratch to make it play when somebody stepped on that particular piece of road. So molecule. What is a molecule again that Justin just said there? And what molecule do we see here in front of us? Nicola.
A water molecule.
A water molecule. And what makes up a water molecule? What atoms make up a water? There are 2 types of atoms that make up a water molecule. Nicola, 6th class.
2 hydrogen and 1 oxygen.
Yeah, 2 hydrogen atoms and 1 oxygen atom. And when they're joined together, they form a water molecule. So what we can do is if we touch the oxygen atom, it says touch the red oxygen to make a water molecule. Very good. So who made that? In the 5th class, how did you go about doing that?
We built spheres and cylinders, and then we used Scratch to make the ball go up.
Very good, very good. So that when somebody touched it, and there's even a little message there saying, well done, you've just created a water molecule. Now, let's move down. You can also, if we added another oxygen atom to a water molecule, we'd have H2O2, 2 hydrogen and 2 oxygen. And what is that called? What type of a molecule is that called? Justin, 5th class.
Hydrogen peroxide.
Hydrogen peroxide. Now, H2O is safe to drink, isn't it? What is H2O, Jamie? H2O is?
Water.
Very good, Jamie, 3rd class. And what's H2O2? Hydrogen peroxide, often used as a bleach or a cleaning agent. So that leads us on to, who made this particular molecule here, by the way? Rachel, 5th class. How did you go about making that, Rachel?
I got cylinders and spheres and changed the colour of them.
And join them up together. Very good. Okay, so we'll walk down to our chemistry cat. Here's a joke based on the H2O and the H2O2.
H2O2 is often used as a bleach or cleaning agent.
That's you, Amy, isn't it? 5th class. Good. Now, who's going to read out the joke for me? Who wants to read out the joke? Rachel, will you read it out?
2 men walked into a bar. The first ordered some H2O. The second one says, that sounds good, I'll have some H2O too. The second man died.
Very good, very good, very good. And yes, we'll walk down now to a bit more complex molecule. What's this one called? Justin, 5th class.
An amino acid.
Yeah. Amino acids. Now, why are amino acids important? Why are they important? Rachel.
You need them to live.
Exactly.
There are
You need them
20
to live.
different kinds of amino acids.
So, that's Thomas, is it? 4th class. Very good, Thomas. There are 20 different types of amino acids. Now, can we make all the amino acids that we need in our own body? There are 20 different kinds. Do we make all of them? Jamie, 3rd class?
No.
No. How many do we make in our own bodies? Rachel?
10.
10. Now, there are some living things that do make all 20. What are they in the 5th class?
Plant.
So what do humans need to do to get all 20? Rachel?
Eat plants or animals that eat plants.
Exactly. So if animals eat the plants, they get the 20, so we can eat the animals. Or else if we eat the plants, then we get the other 10 that we need to live. Now, do they stay in our bodies? If we just eat the plants once, does that mean that we're fine then for the rest of our lives?
No.
You have to eat, don't you? Every day you have to because they don't stay in our bodies. So we have information there on the amino acids. And what are the different types of? If we just a quick look to the left here, who did this? Who made the that particular sign? Just on the end of 5th class. Now, what are the different types of atoms that make up amino acids? Nicola, 6th class.
Nitrogen, oxygen, carbon, and hydrogen.
Yeah. And also a little sulfur. So, and who made that? How many people did it take to make this particular molecule? So Justin and Enda in 5th, Rachel and Amy in 5th class. And Amy, how did you go about making that? Was it hard?
Not really. You just need to get cylinders and spheres and join them together and rotate them and change the colours.
Excellent, Amy. Well done. That's great. And what are the type of foods that we need to eat if we need to get all of our amino acids? Rebecca, what type of foods do we need to eat to get all the amino acids?
Milk, eggs, chicken, bread.
Yeah. And what if you're a vegetarian and you don't eat animals? You don't like to eat meat or even fish or anything like that? What would be good to eat to make sure that you do get all of your amino acids? Amy?
Milk and eggs and bread and bananas.
Yeah. And what else? A couple of other things?
Lentils.
Apples and peanuts and chocolate or red wine, things like that. Okay, so we move down now. We're going to come to a really complex molecule. And what's the name of this particular molecule that we see here? Took Thomas?
It's the DNA molecule.
Excellent. Okay, so what is DNA is like a code, isn't it? And what is information does DNA tell you about a person or about an animal, about anything? What type of information does it give you?
Well, it could give you samples of their hair.
Yeah, not so much, but what information does it give you about your hair, Marie?
Your hair color or your eye color?
Your hair color, for example, or your eye color. And is everyone's DNA the same? Jamie, is everyone's DNA?
No.
No, it's not. No, that's why it's used as in forensics, isn't it? That police departments use it to investigate crimes, because if someone leaves a sample of their DNA behind, it's as unique as a fingerprint, and each person's DNA is completely unique. Now, who made the DNA, which is shaped going right up into the sky there, is it like a helix molecule? Diane and Nicola, was it 6th class? So how did you go about making that, girls? Diane?
We made spheres and cylinders and like a hollow sphere, and we joined them all together, and we just copied them and twisted them around.
And what do the colours signify?
If the nucleus of a cell was the size of a tennis ball, there would be 7 kilometers of DNA in it.
And what do the colours signify in the DNA there?
Different bits of information.
Okay, different bits of information. Now, who was that? Who was that voice we heard in the background? That was you, Diane, is it? And so if the center of a cell was the size of a tennis ball, it would contain 7 kilometers of DNA. And why is there a picture there of the Encyclopedia Britannica?
Because 1 cell of DNA is equal to 30 complete sets of the Encyclopedia
Britannica. Now, how did we go about these here? This particular, I see the CD, is you don't see any border around it. So we made. Diane, I think was it that you were the only person that used Photoshop. Now, what did you do in Photoshop to make it invisible around the CD? Or how did you go about making that?
I went on to Google Images and I got a picture of a CD, and then I went into Photoshop and I clicked on all 4 corners to get rid of the white background, and then I just saved it as a PNG file.
Very good. So you have to save it as a PNG file to keep the transparency, wasn't it? And then uploaded it again. Very good. And what's this particular cuboid you made? Invisible, isn't it? And then you put the text around it. Very good. Okay. So if we fly, we might try fly up our and the page up just to see how, just to give an idea of the scale of the DNA molecule. Now, how did you make all of those, guys? Nicola, how did you make all of those little bits individually, one at a time?
No, when we made one, we copied the other, but when we had a few made, we just copied them and joined them together.
Okay, excellent. So if we can stop flying and we fall back down to Earth safely, hopefully. We see all our domes there, and that's where we're headed. That's where we're headed for next. We're headed for the next white dome down the purple road. Okay,
DNA is a complex molecule that contains the genetic code of all living things.
Right. And now we come to, what type of dome is this?
It's the starch domer. Or the quiz dome, I mean.
Yeah,
Welcome to our game called Snakes and Domes.
Very good, very good. Okay. Right, so here we are at our interactive game, Snakes and Domes. Now, who can explain to me what this is about? Okay, Nicholas.
Well, you have to answer a question, and if you get it right, you proceed to the next dome. But if you get it wrong, you'll be teleported back to where you can get the right answer.
Okay, and who made the snake there at the side? Diane in 6th class, and you did that the same way as you did the CD, was it, Diane? Okay, very good. Now, let's walk over to see what the first question is. Who's going to read out the first question? Thomas, 4th class.
How many protons has a hydrogen atom?
Now, would 4 be the right answer? No. So let's click on 4 and see what happens. Right. Okay, so let's click on. Is 4 the right answer? No, it's not. So let's see what happens when we click on 4. Now we turn around and see where we are. The answer you seek is very near. Now, who made that? Rebecca.
Well,
Nicola typed it, but I put it up.
And many of those have you put up?
On all the signs with the answers.
Okay, very good. So we'll go around and see if we can find the answer on the other end of that sign. How many protons has a hydrogen atom? Does anybody know? Can anyone tell me? Joseph in third class.
1.
Very good, very good. And we can see it there. So now we're not going to walk back. We're going to fly right across, not the whole way around the road again, but we can fly straight across to the white dome. Just down to your right and off. That's it. So back down to here, down to the white dome, down to our quiz dome. And Joseph, what is the right answer again?
1.
Right, so 1. We're going to try 1. Right, now we're through to somebody's dome here. Whose is this dome? Okay, Jamie and Joseph, is it, in third class? Okay, Jamie, can you tell us a little bit, and then Joseph, you tell us a little bit about what can be seen here.
We're in the ice cream shop. There's a huge ice cream behind that big cylinder, and there's the till that we were almost behind, and the big cylinder is for the money.
Okay, very good. And if we just turn around, there's a little door. We can walk through the doorway here. And that will bring us on to what are we going to see when we get to walk through that door, Joseph?
We're going to see a chair and a round table that's a sphere.
Okay, very good. And just before we move on to your question, excellent, very good. What you also made, you made a little hidden room upstairs, didn't you? So if we just fly and just up now, we're just going to have a look around, and you can just tell us what's in there. And page up. Now we just have a look around, and Joseph, will you tell me what can be seen here and who made it?
There's a shelf that I made and a lamp that I also made. There's a bed and a poster and lockers and a chest of drawers.
And what's on the poster?
Simpsons.
Okay, and how did you upload that? How did you get that on?
I went on to Google Images and saved it, and I went into File and Upload Image, and it was in my texture.
Very good, and added that sort of cuboid shape. Excellent. Okay, so if we stop flying now, we'll go around and see what your question is. And Jamie, will you read out what your question is? Let's see where.
Which is lighter?
Now, which is lighter? The 4 options: hydrogen, helium, oxygen, or carbon. Now, which is lighter? Into 5th class.
Hydrogen.
Hydrogen. That's it. Excellent. So we click on that, and we're teleported onto the next dome. Now, whose dome is this? Thomas. And 5th class, can you tell me a little bit about your dome? We're just going to look around for it. Or in 4th class, sorry.
There's a box with a tree in it, and there's meant to be clay, but I forgot to put it in. And there's 2 tables, and one of the tables has a fruit bowl with oranges and apples in it. And there's bunk beds, which I made, and it was my idea. And there's a roof thing that was meant to be a roof, and I forgot it. And there's a couch and a piano.
Very good. And if you just maybe walk backwards, we'll just walk backwards a little bit and then turn around, and we'll see the couch and the piano. Is that the piano? We're at the back of our piano. Okay, very good. If you turn right around, I think, yeah, that's it. Okay, very good. That's the piano, Thomas. Very good. And you have a pot of you have a pot of plant in there as well. Okay, and your question. Someone read out. Rachel, will you read out Thomas's question?
What date did the Hindenburg crash?
And what date did the Hindenburg crash? Nicola?
May 6, 1937.
Okay, so we'll select that as our answer. Now we're through to this particular room. Okay, and in here, whose dome is this? This is Justin, Endes, and Connell's. Okay, so Connell, what did you make in here? What can we see in here in this?
A cupboard, posters, a bed, and a lamp.
Very good. And where did you get the pictures for the posters?
Google Images.
Good. Okay. And the cupboard, where did you get the texture for that as well?
Google Images.
Okay. Very good. What else is in there? Anyone else? Justin, do you want to tell me anything about your that dome?
Well, there's a bed and there's a lot of funny pictures around the place.
Yeah. Okay, very good. And if we walk through If we turn around, in fact, if you use, yeah, if we walk in there, just walk through. There's a hallway here at the end, isn't it? Because we're going to try and find your question. Right. So, Justin, Linda, will you tell me what you made here in the bathroom?
We made a toilet with a toilet roll, a bath there, as you can see, and we made a sink.
Excellent. Very good. And you even put the taps on the sink as well. Very good. And so we move over to your question now. And the question is, what's your question, Linda?
How many different types of amino acids are there?
And how many different types are there? Amy, 5th class.
20.
20. Okay, so we go with 20. Right, now we're through to, and if I look up here on the left, the sign, we say, hello and welcome to Rebecca's, Marie's, Amy's, and Rachel's dome. Okay, now, this is very dark dome, so can we just see if we change the sky? Is the sky anything to do with it? Is it gone back to, or is it still in blue midday? No, it's still in blue midday, it's just a dark dome. Okay, so, now, Amy, what did you make in here? Amy, 5th class.
A fireplace, a table. Me and Rachel made a computer, a chair, cupboard, bunk bed, table, plates and cups, bathroom, trees, and bookshelf.
And a bookshelf, okay. Okay, so if we just go over and have a look in your bathroom, maybe. I think it's behind there. Just have a walk over there. What did you make, Rachel, in here?
I helped even make the bunk bed, and the shelf and the computer.
And the what?
TV.
Very good. Okay, Rebecca and Marie, what did you make in there?
I made 2 of the signs up on the wall, and I made the picture frame with the Smurfs on it.
Very good. And Marie, what did you make?
I made the bunk bed and a few of the pictures.
Very good. Okay, now in the bathroom, what can we see here in the bathroom, Amy? Tell us what's in here.
A toilet, a bath, a sink, a toilet or a plunger, a toilet roll holder, a toothbrush, a table, and that's it.
Very good. And how did you get the water in the bath?
You make a sphere, you flatten it down, put it into the bath, go into texture, and it's called water 1, and you click it, and then you go into pick blue that you want, and it turns light.
Good, very good, Amy. Okay, that looks really impressive. Now, so we go over to your question. Now, girls, while we're walking over to your question, what is can someone read it out for me? Rachel.
What is H2O2?
And what is it? Thomas.
Hydrogen peroxide.
Hydrogen peroxide. Very good. So now we're into the who made this dome? This is Nicola, Orla, and Diane. Okay, so Orla, can you tell us what you can see in here?
Bed.
Yeah. What and whom? How did you make the bed?
Cubes.
Cubes. And
I didn't make the cupboard.
who made the Nicola? What did you use beside the bed?
A cylinder.
Okay, very good. And what else? Anything else to be seen in this room? Okay, who made the plants? Who brought in the plants? Orla was it? And who made the couch? How did you make the couch, Orla, and get the cushions to sit on the couch?
That's the time I had on the bed, but
Yeah, how did you get the cushions to sit on the couch?
I didn't do the cushions.
I rotated it, held and control and push it where I wanted to.
Okay, very good. Now, what's your question over here? And this is a lovely cupboard here. How did you get the clothes to hang in the?
I just copied and pasted. I just made one keyboard and I copied and pasted them and changed the clothes.
Very good, very good. So it looks very, very impressive. And if we go to your question. Now, Dan, will you read out your question?
If the nucleus of a cell was the size of a tennis ball, how many kilometers of DNA would it contain?
And who knows the answer to that? Rachel, 5th class.
7.
7 kilometers, yeah. Very good. Now we're in our final dome. And who uploaded the pictures on here? So we have pictures of each person in the room, everyone that worked on MissionV. Who uploaded the picture? Rebecca, 5th class. How did you go about doing that?
Well, I made a cuboid and I made it invisible, and I put pictures up on it.
And where did you get the pictures from? Who had made the pictures for you?
Diane.
Diane. And Dan, you used, what did you use to make the pictures?
Photoshop.
Very good. Okay. So it says you passed our test. You're very clever. Better than all that. Who made that up? Rebecca, wasn't it? And so we touched the sign to leave. Go Gortskehy, yeah. Now, so we're outside on our the center of our virtual Mission V. So that's just we just fly around and with different pictures of other things we do in school. So we have, what have we got here? Can someone tell me what we can see here, Jamie?
Bounce-a-thon is one of them.
Yeah. Anything else, Amy?
When we went on our trip to Belfast.
That's right. When we went to the can anyone think of the name of the place we went to in Belfast? Anyway, so we did great science experiments and everything. Rachel?
W5.
W5, the W5 in Belfast. That's down there in the bottom left. Now, what else? If we just move back a little bit, there are a couple of pictures there at the top. Thomas?
Me and my friend making our communions.
Very good. Your first Holy Communion. And what else is the middle one there? The middle picture, Rachel.
The vegetables from the garden.
Vegetables from the garden. And who's in the last? The two pictures there?
Me and Joseph.
Computer. Very good. Okay. And we fly around the other side. We'll just have a quick look at the other side. And if you just want to fly back a bit out from it, Lisa, that'd be great. Just yeah, fly out there and then turn around. That's it. Now, what are the? And maybe just go back a little bit because, yeah, that's perfect. Now, what do we see here, Nicola?
Our trip to Dublin to the Helix.
Yeah, and what do we go to the Helix for?
For the Junior Spider Awards.
Okay, very good. And what's the other picture to the left then of that one? Rebecca?
After confirmation.
Very good, a confirmation class. And then the last side, we have 4 more pictures, I think. And can someone tell me, who's going to tell me what those are? Connell, one of those pictures there, what's happened?
The circus down the bottom.
Yeah, the circus. When did the circus come to school?
Last year.
Last year, very good. Okay, what else is happening there? Amy?
When we got into the final of the Heaney Shield.
That's right, the Heaney Shield. Yeah, that's right. And did we win the Heaney Shield this year?
Yeah.
Yeah, we won the Heaney Shield this year. And what else? There are 2 other pictures. Inda, 5th class. What's happening to the other 2 other pictures?
One of them is the school play.
Very good. The school play, the school Christmas play. And the last picture, Rachel.
Practicing for a score.
Very good. Practicing for score. Okay, and we just fly up over the top just to finish off to see what's at the top of our cuboid. So what's the symbol of the school? What is the symbol of the school, Amy?
White thorn.
And why is it the white thorn, Rebecca?
Because their school is surrounded in white thorn. Like it's the field of white thorn.
Yeah, the field is surrounded by white thorn. And what year was the school founded? Anyone know?
1887.
So this year, or next year, 2012, how old will the school be? Does anybody know? Connell?
Years. 125 years.
125 years old. That's it. So very good. You should be very proud of your work. Excellent work. Well done.